Welcome to Solving Time Value Money Problems with the BA2 Plus Financial Calculator. This is the second in a four-part series designed to help you get the most out of this powerful little device. In this video, I'm going to be showing you how to solve any annuity problem with the TVM Worksheet. When I say any annuity, I mean the ordinary annuity, where repayment takes place at the end of the payment period, as well as the annuity due, where every payment takes place at the beginning of the payment period. And what I'm going to do for each of these annuities is I'm going to show you how to find their present values, their future values, their internal rates of return, the size of the annuity payment, and the duration of annuity or the number of payments in that annuity. And that ought to pretty much take care of everything you need to know, because that pretty much takes care of everything there is to know as far as annuities are concerned. We'll begin with the calculator and turning it on. And when we turn it on, the calculator defaults to the TVM worksheet. All you have to do is clear it and you're ready to go. We're also going to use the same time value of money keys that we used previously. These keys are dedicated to the TVM worksheet, only this time we're going to use the payment key rather than the future value key, because that future value key was for a single future sum. We also have to pay attention to the interest rate key, because that interest rate key is for annual interest only. And if we have interest that's other than annual, we have to make a slight adjustment to that interest rate so that we can use that single key. And we're also stuck with this design quirk that the engineers at TI left us with when they decided that whenever we had an investment problem, that required us to take money out of our pockets. Hence, they decided that every single problem in the TVM worksheet, whether it be a single sum or an annuity, have a minus sign to reflect the taking the money out and putting it in the investment, even though that minus sign turns out to be mathematically meaningless. So what we have to do in this worksheet, in this video, is learn to use that minus sign, even though it's mathematically meaningless. So we're going to have to use it, ignore it simultaneously. I'm also going to show you a quick shortcut that's really going to speed things up, and I think you'll like it. Now, before we start, what we have to do is tell the calculator which type of annuity we want to work with. Do we want the annuity where the payment is at the end of every period? That would be the annuity, ordinary annuity. Or do we want a payment where it's the beginning of the period? That would be the annuity due. So we start by clearing our calculator. And the next thing we do is we'll look for the begin key. Now the begin key is in white letters on a black surface. And that really is a start key. And what we're telling the calculator is we're starting to program it for the type of annuity we want to have. So once we hit the begin key, next thing we do is hit second set. We hit second set, we might see begin in the display, or we might see end. But every time we hit second set, we're either going to hit begin or we're going to hit end. And, you know, we can toggle back and forth, hit begin and whatever. And these two commands up in the display are used to tell the calculator which annuity we want. Well, I want the ordinary annuity for a problem, so I'm going to leave it on end, and I'm going to hit second quit, and that's going to lock it in. And now we can use these four commands, clearing the calculator, then second begin, then toggling around with the second set key to get to the quit key, to set up our program for the annuity, type of annuity we want. So we begin with our first problem. And I'm going to continue with my technique of putting a quick little illustration to go along with the words. And you can see that I've drawn the annuity as an ordinary annuity. Now, how do I know if it's an ordinary annuity when it doesn't say so? Well, it says it's annuity. Well, it turns out that the word annuity is commonly used for ordinary annuity. People seem to leave the word ordinary off. They don't leave the word annuity due off if it's an annuity due. Okay, they'll always tell you that. But if you just see the word annuity by itself, you can safely assume it's an ordinary annuity. So I draw this up as an ordinary annuity. Now, another reason I like to draw it up this way is because it helps me pull all the numbers out of the problem and make sure I've accounted for everything. And it looks like I've got four regions. I've got present value, I've got the payment, I've got the interest rate, and I've got the N over here. And those four regions in the diagram correspond to the present value annuity equation that we have here. So for example, we have a present value, we have a payment, we have an interest rate, and we have an N. Now, the N is going to stand for the number of compounding periods in the problem. That's important, okay? Sometimes, if we don't have any compounding, then the number of compounding periods in the problem will be exactly equal to the number of years. But if there's compounding, it's going to be different, and we want to pay attention to the number of times it's compounded. I'll do away with my symbols here. And one thing we know is that if we have the algebra problem and we have values for three of these four, we ought to be able to find the answer. And that's the way the calculator is designed. So let's put the algebra away, start with the calculator, and we will clear it. Next thing we do is we have to program it for an ordinary annuity. So I hit second begin. Then I toggle with second set, until I see end beer in the display. Once I see end in the display, you see it there, what I'm going to do is hit second quit. That locks it in. Now I'm all set for an ordinary annuity. I put my $100 in as a negative sign. That's the quirk that we talked about a minute ago. Now, every problem is going to have a minus sign. Either I put it in and get it out of the way so I can have a positive answer, or the calculator is going to put it in as a negative in my answer. And I don't like to see negative answers, so I like to put the minus sign in and get it out of the way first. So I put the $100 in as a negative amount. Next, I put in the interest rate and the number of years and compute the present value. And it comes out to 303.73. That's pretty easy. So I'm going to do the problem again. Well, this time I'm going to put compound interest in it. And you can see that I've got 12% discounted monthly. Now, whenever I read through the problem and I see that I have interest that's compounded other than annually, what I like to do is flag it. And I might circle it or underline it or put a star beside it. Just do something so that when I'm working with the calculator, I don't overlook that step. All right. Now we can start with the calculator. Don't forget, this is an ordinary annuity. We have to program it for an ordinary annuity. Okay, second clear TVM, second begin, second set, until I see end in the display. Once I see end in the display, second quit, I'm done. I've now programmed my calculator for ordinary annuity. I put my numbers in. 100 as a present, as a payment. Now I get to the interest rate key. I don't do anything with it yet because you see I have monthly compounding. So what I'm looking for is I'm looking for a single rate of interest that is exactly equal to 12% compounded monthly. That interest rate would be the effective interest rate. And I find that effective interest rate this way. I divide the 12%, 0.12, divided by 12. I divide it by 12 because there's 12 compounding periods in the year. I add 1. I raise it to the 12th power because there are 12 compounding periods in the year. I subtract the 1. I have the decimal equivalent of the interest rate, and I need the integer in the calculator for the worksheet. So I have to multiply it by 100. Then I have 12.68, what's that, 2 something percent. All right. Now, I have the numbers in the calculator is telling me, I look in the display, 12.68%. And it's not yet in the worksheet. It's not in the worksheet until I hit the interest rate key. So I hit the IY key, boom, like that. And now that 12.68% is saved in the worksheet memory. Now, don't worry about leaving any decimals off and having a rounding error. That's not going to happen. This calculator carries every computation out to 13 decimal places, so you have plenty of accuracy. So I've got my interest rate in. All I have to do now is put in the end and solve it. So I put in the end, compute the present value, 299.42. And unsurprisingly, that present value is just slightly smaller than the 303 because with a higher rate of interest, those discount paths are a little bit steeper, and that those sums come back as smaller amounts. Not much because we have a short annuity, but we don't really need a long annuity to illustrate this problem. Now, I'm going to use the same problem again in problem 1b. And what I'm going to do is show you how I can solve a shortcut. Because, you know, when I programmed the calculator, I did this. I had second clear TVM. Then I hit second begin. We got the begin key, second set, until I got end in the display. Then I hit second quit to lock it in. That takes a lot of steps. I don't like that. I'd rather do this. I'd rather hit second reset enter. Now, if I hit second reset enter, that does two things simultaneously. It clears the calculator, and it simultaneously sets the annuity setting back to the ordinary annuity setting. So I've set it for ordinary annuity, and I've cleared it simultaneously. So instead of doing this, I can do that. Okay? Now I can put my numbers in to get my 299.42. I like the shortcut. Of course, that's not the user way, the way the user manual does it. And the user manual does it a little differently. I think I probably ought to show it to you. So here it comes. So if the user manual wants to do this exact same problem, all right, first thing we're going to do is program it for an ordinary annuity. All right, second clear TVM, second begin, second set until I see the end, second quit, I've locked it in. Now I've got the ordinary annuity. Now we can put the numbers in, but careful here. I have to hit second PY, and then I should see a 1 in the display. And if I don't put 1 in there, because when you hit second PY, look at your display and you will see it say PY equals something, probably 1. Make sure it says 1. That stands for payments per year. Okay, we want 1 payment per year, so we hit enter second quit to save it. Next, we use a 3 keystroke combination, second PY down arrow key, and that combination of keystrokes brings up the C/Y menu. If you're looking in your display as you're going along, you'll see that C/Y is equal to something, probably 1 right now. But we have 12 compounding periods in the year, and that's the C stands for compounding periods in the year. So we want it 12, so we put 12 in, and we want to save it, so we hit enter second quit. That takes care of all the compounding for us. Now we can put the number of years in, 4, second, times PXY in, a lot of steps. And now we can put in the rest of the numbers. We can put 12 in as the interest rate. We don't have to do anything to it, just put 12 in as the interest rate. Put the $100 in as a negative amount, since it's a payment. And then compute the present value. You get $299.42. Wow. All right, but we're not done yet. And that's because what we've done is we have programmed the calculator for 12 compounding periods right here in the year. And if we don't change that, every problem you work from now on is going to have 12 compounding periods in the year, whether you want them or not. So we have to reprogram the calculator back to 1 compounding period in the year. And the user manual says you can do this, hit second PY, second clear worksheet. Now the worksheet is a different key. It's the CE/C key down in the lower left hand corner. Okay, so you clear it, and that sets it back to 1, so you're safe. Or of course you could hit second reset enter. That also clears the calculator and sets everything to back to factory settings. So you either go through all of those steps, or you use my shortcut, which looks like this. And I've used 2 shortcuts actually, because I use the second reset enter. That's one shortcut. And then when I've got the 12.68% interest rate, that's another shortcut. But I think that the combination of the 2 shortcuts is better, because if you don't program your calculator for something other than annual, you don't have to deprogram it. And that can occasionally be a problem, because you'll be working through all this and you get down to $299.42 if you're using the user manual solution, and if you get all excited and write it down and forget to reprogram it, then you're going to have that programming of 12 compounding periods in the year for every problem you work in the future. So the shortcut is a little bit safer because it doesn't, do the compounding and uncompounding. Well, that's the comparison of the two. So let's do the present value of the annuity due. Now, that may not make a lot of sense all the time, but I promise to show you the present values for each one of the two annuities. So let's set the calculator up for an annuity due. We draw a diagram first. There it is. Okay, let's set the calculator up. Now, we hit second clear TVM, second begin, second set. We hit second set until we see begin in the display. Then we hit second quit. Then we can put our three numbers in, and then we can find our answer, and our answer comes out at 340.18. If you look at that problem, it also appears that this is the same thing as a 3-year ordinary annuity, isn't it? Plus an initial payment. So if I were to use my shortcut method to find the present value of the 3-year ordinary annuity, I would get 280.18. But don't forget to add that initial payment, and I would have 340.18. So finding the present value of an annuity due, you can do it two ways. You can do it the long way or the user manual way, or you can use the shortcut, and don't forget to add the initial payment. Okay, problem number 3. Now let's see, we want the future value of an ordinary annuity, and it just says annuity, so I know it's an ordinary annuity. Okay, I'm looking for the future value of all those sums. It looks as if I have 3 of my 4 variables. So, shortcut, right? Ordinary annuity. Second reset enter. Put in the $100 as a negative amount. Work out the effective rate of interest. Now this time it is weekly, so I have to put 52 in my denominator. 0.12 divided by 52 equals plus 1 equals y to the x, 52 equals minus 1 equals, and you've got 0.1273. It's not an integer yet. Multiply it by 100. When it says 12.73, tap the interest rate key. It'll be saved to the worksheet, and we're now ready for the next 2 steps. Put in the n and compute the future value, 483.07. Problem number 4. Future value of an annuity due. Okay, well, this is fairly easy. So it's an annuity due, so we're going to set it up as annuity due. We hit second clear TVM, second begin, second set, until I see begin in the display. Then I hit second quit to lock it in. Now I've programmed it for the annuity due. Put in the rest of the numbers, and when I work it out, it's going to be 544.62. By the way, since I worked out the effective rate of interest in the previous problem, I didn't bother to do it out a second time. It's right here. It's that 12 divided by 52 plus 1, raise it to the 52nd power, subtract the 1, multiply it by 100, and then you're all set. Why didn't I hit second reset enter? Well, if I hit second reset enter in this problem, that would have set it back to an ordinary annuity. Remember, we have an annuity due, so I can't use the shortcut for the annuity due. The internal rate of return of annuity. Now the problems would get a lot harder, except maybe you've seen the answers up now, so you know what's going on. But we have a 4-year $100 ordinary annuity, has a present value of 303.73. So here's the diagram. But think of how hard that would be to work out if you didn't have the BA2 calculator. How many times would you have to try out different interest rates, taking each one of those future sums and discounting them back to the present value to see if you got exactly 303.73? And if your interest rate was too high, you'd have to lower it. If your interest rate was too low, you'd have to raise it. And you have to do that a lot. Not in the BA2. So we have a shortcut. It's an ordinary annuity. Second reset enter. Put in the numbers that we have. The 100, negative number, 303.73. 4 is the n. Compute the interest rate. It's 12%. But I said you'd know the answer because you'd seen it before, right? Let's take a look at 6. This one's a little harder to guess. You'll get close, but you won't get it exact. So now we're going to start off with 303.73, and we're going to try to find the size of the payment. What I want to do is put that money in an account at 12% compounded daily, and I want to take out 4 amounts all in the same size and exhaust all those funds at the end of 4 years. I have an ordinary annuity shortcut. Now I put in the numbers. I have 303.73. I stopped here to show you the daily interest rate. So I divided the 0.12, the 12%, by 365, added the 1, raised to the 365th power, took the 1 away, and had the decimal for as many places as I wanted. But I only needed 2, so I just hit the I/Y key, and that set it into the time value money memory. But, you know, you might ask, does it make any difference whether you use 365 or 360? And the answer is, yes, it does, after the 5th decimal place. But for problems like this, probably not so much so I wouldn't worry about it too much. But nevertheless, it can make a difference. Let's finish our problem. Put in the 4 as the n. Work out the size of the payment. The payment is 101.58. Now, you knew it would be close to 100, but you didn't think it would be exactly 100 because of the interest, right? Right. Here's one you can't guess. Duration of annuity. Now we have 303.73, and we're going to fund an N-year annuity of $100. How many payments can I make? And I'll raise the interest rate I'll double the interest rate to almost 23.75%. There's my diagram. So I have the present value, I have the size of the payment, I have the interest rate, I have 3 of my 4 variables that I need. I don't know the N. So this is an ordinary annuity, shortcut, right? And most of the annuities you run into are going to be ordinary annuities. You can use the shortcut a lot. So then I put my numbers in, ready for the answer. Turns out to be 6. Okay, so I could make 6 annual payments of $100 and exhaust all the money that is in that bank account. Now, I think that takes us to the end of everything that I can say about annuities. And what I've done is I worked with 2 annuities. I've worked with the ordinary annuity, where the payment is at the end of the period, and the annuity due, where the payment is due at the beginning of the period. And I've showed you how to compute the present values, the future values, the internal rates of return, the size of the annuity payment, and the duration of the annuity in cases where we have simple interest or compound interest. And that ought to take care of any problem that you ever run into. Now let's go back and summarize some of our shortcuts. Back when we were in the first video, I said, look, if we have a problem with a single sum with compound interest, the user manual said, do it this way. I said, well, okay, it's probably easier if you do it that way. Well, now, in the annuity problems, it turns out if we have an annuity and the user manual says exactly the same thing, so the shortcut is exactly the same thing, that means that any single sum or annuity problem with compound interest, you can use my shortcut way over here on the far right. And when we had ordinary annuities, the user manual said, do it this way. I said, it's probably easier if you do it that way. And now you have 2 shortcuts to go along with your knowledge of how to solve all of these problems. So this takes care of everything in the TVM worksheet that I can think of. And we're going to move into the next worksheet, which is for uneven future sums. And that is a whole different animal. It is set up differently. It has different assumptions. Interest rates count. But it's one of the most powerful worksheets, and you'll need to know how to use it. So I'll see you in the next video.